All right, good morning, everyone. Again, my name is John Pendleton, and I'm going to be doing the tech time today for Jim, because he is out of the office, out on a site visit. So just take some notes. If you've got questions, you can ask during the webinar through the question feature, and I'll get to those, or I'll send them over to Jim, one of the two, and get those questions answered after the webinar. You can sign up for our tech time through intertechusa.com. Intertechusa.com is our secure site, and there you can find parts and you can file warranties and things like that. So if you register on Intertech USA, you'll be able to enter our secure site. So it's going to be a short webinar, about 15 minutes. This is my first time doing one of these, but a little bit of background on myself. Again, my name is John Pendleton. Here's a picture of me. I'm the senior trainer here at Intertech, so I do the majority of the trainings. This is just a little snippet that Jim likes to do. So you might have seen me out in the field. I do a lot of site visits, unit startups, things like that. So I've been with Intertech for about 10 years, and so I obviously know the geo pretty well. It's all I've been working on for the past 10 years. So if you need anything, feel free to give us a shout. I do have an email address, so if you're looking for further training, you can contact either training@intertechusa.com, or you can contact me directly at john.pendleton@intertechusa.com. You can also reach out to your TMs if you're looking for a group training, and your TMs will get in contact with me, and we can schedule some further training, whether that be in person or an online webinar such as this. We do have a website, intertechuniversity.com. If you go to our intertechusa.com, in the upper right corner, there's a link for Intertech University, and it'll show any upcoming trainings that we might have, or there's also a curriculum of trainings that we do offer. We also have a YouTube channel. It's actually Intertech University, and all the webinars, all these tech times are recorded and uploaded there. There's a lot of troubleshooting videos, how to troubleshoot a reversing valve and a TXV, a bag compressor, things like that. So just check out our YouTube channel. This is our tech support department. These are the guys you talk to when you call into tech support. Jim Strandlund obviously is normally our tech time presenter. Again, he's out in Ohio today doing a startup on the unit. Then there's myself. We have Kip Western, he's actually our tech service manager at this point, and he lives in Minnesota. Then we have Rob Shawless. He's our tech service rep. He lives in Pennsylvania. Rob's been with us for about a little bit longer than I have here at Intertech, but he actually came from Hydro Heat. He worked for them for about 30 years, so he's got a vast amount of knowledge. So we have Kern Wildhaber. Kern works in design as well as tech services, and he's out this week actually on vacation. So that's the tech support department. We'll go ahead and get started on our mega ohm meters and what they're used for. So basically, a mega ohm meter provides a quick and easy way to determine the condition of the insulation on a wire, generators, and motor windings. So it's basically an electric meter that measures high resistance by sending a high voltage signal into the object being tested. So there's many different manufacturers with differing instructions on how to use them, and it can make it a little bit confusing. There's a lot of HVAC companies out there. They're touting the benefits of testing the homeowner's compressor bearing equipments. It could be a little bit misleading. Are they condemning compressor bearing equipment, just to make a sale? I would hope that, with all the, as seen on the news or whatever, people get busted for trying to condemn components that are good, that we'd hopefully get away from that. But we do have a lot of sales technicians out there. And so we're just trying to understand if they're trying to just make a sale or scare the customer. So we'll look at how we actually are using these mega meters. There's many different brands that are available. You can use an ohm function, and there's also a mega ohm function. So there's a couple of different types of ohm meters out there. Here, this is showing a little triplet multimeter here. This is a field piece, digital version. Again, just a field piece here. So the field piece that we just showed the picture of, the SMG5 mega ohm meter, is for fast, easy, and safe testing of insulation resistance. So basically, it provides a 1,000-volt source. It monitors current and displays the resistance between the test points. So maximum current output on that field piece is less than 1 milliamp. And it does have an automatic shutoff feature. The SMG5 can be used to determine the condition of the insulation from winding to ground in the motor, compressor, or a transformer. So disconnect the windings and measure the resistance between the windings and ground through the insulation. So you're going to have to determine what a good reading is by comparing your readings to values supplied by the manufacturer of the equipment. So if you've got a Copeland compressor, we will get those values from Copeland or Emerson. You're going to want to make sure that when you're taking those measurements that you're comparing the readings at the same temperature. Obviously, temperature is going to affect resistance. Mega ohm readings work best when the same equipment is measured over time. So you can start to see basically a pattern, is it getting worse over time? Basically, a decreasing insulation resistance level, you can forecast it before a catastrophic failure occurs. So here's another little mega ohm meter. This one just has some lights on it, and it'll display the mega ohm reading based on the color of the light or where it's at in this slide here. So that SUPCO meter, pneumatic motors require special test parameters since the windings operate in an oil and refrigerant atmosphere. So under normal conditions, the oil and the refrigerant have a high electrical resistance. However, when they're contaminated with moisture, the electrical resistance changes and you'll get a low mega ohm reading. So if we look back at this SUPCO here, you can see the resistance level where this red light is on top, where it's bad, is a low resistance. And then a good reading would be a much higher resistance reading. So if you've got contaminated with moisture, then it's gonna end up giving a low resistance. New pneumatic motors have a resistance value of more than 100 mega ohms. Readings of 50 mega ohms or less would indicate either the winding insulation is deteriorating or the oil/refrigerant is contaminated. A lot of times you can have an odor, so you can kind of tell if that oil is contaminated, but you can install an oversized dryer and you can clean up the system, or you could take all the refrigerant out and replace the compressor oil. In either case, if the mega ohm test shows even the slightest improvement in resistance value, the remedy may have checked a declining condition. So you could definitely be on the right path there. A good rule of thumb is to smell a small sample of the oil. At any time in the history of the unit, if the motor was severely overloaded, it will leave a telltale trace in the oil that can't be removed. The only way you're going to get rid of that smell is by removing the refrigerant, dumping the oil, and adding more oil to the system. The odor of burnt insulation is easily recognized, and a low resistance value of 20 mega ohms or less will verify the motor insulation is severely damaged. So basically, we've used mega ohm meters, for a very long time to evaluate compressor motor windings. However, most mega-ohm manufacturers publish guidelines that apply to open motors. For this reason, Emerson, which is where we get our compressors from, has investigated the use of mega-ohms on hermetic and semi-hermetic compressors. So when using mega-ohm meters to evaluate the motor installation of a compressor, it's important to understand that they should not be used as one would a volt-ohm meter. A single mega-ohm reading gives little insight into the condition of the installation itself. You want to use a mega-ohm meter as part of a regular maintenance program, so you can follow trends over several months or several years. So for an example, one might record a mega-ohm value and compare that number to maybe when they installed the unit, they took a mega-ohm value and they wrote that down. So you could compare it over time to see if we get a lower and lower value. If you do, then you know that there's a trend, there's something in the system that needs to be cleaned up and taken care of. So Emerson, when they make these compressors, they do not use a mega-ohm meter in their quality checks. They use what's called a high pot current leak test, which is a high potential current leakage tester, or a high pot test. And so studies performed by Emerson have found the compressor with mega-ohm readings as low as 0.5 mega-ohms may still pass the high pot testing. So there's many factors that affect mega-ohm readings. Again, a good instance would be contaminated refrigerant. Basically, there's refrigerant in the oil and current leakage to the electrical fuses and the terminal plates. Any external electrical component connected to the compressor terminals will also affect the mega-ohm readings. So wires, contactors, relays, they all leak current and will decrease the compressor mega-ohm reading if they're not disconnected. So as mentioned earlier, a single mega-ohm reading cannot be used to condemn a compressor. You would use your volt-ohm meter for that, short of the ground. Something like that, shorted across the windings. However, limits can be placed on mega-ohm values that dictate action, the action be taken. Emerson has found that these limits are related to the rated voltage of the compressor. So mega-ohm values equal to or greater than 1,000 ohms per volt are probably acceptable. So an example, a 460 volt compressor might show a mega-ohm reading of 460,000 ohms or 0.46 mega-ohms. So compressors with rated voltages of 208, 230 would then be operable at a mega-ohm value of 0.208 to 0.230, or 208,000 or 230,000 ohms. For simplicity, Emerson has set the limit at 0.5 mega-ohms before a compressor is condemned. You can see again that 460 volt is 0.46, and the 208, 230 would be 0.208 and 0.230. New compressors that have never been installed will not need any system cleanup procedures so long as the mega-ohm reading is above 5. So a baseline reading must be established for comparison purposes. And since this is the first reading, that 0.5, that would be the baseline value. So then when you come back in 3-4 months, you can check it again, come back in 6 months, check it again, that 0.5 would be your baseline. This is a little handout from Emerson, and if you would like this handout, shoot us over an email at training@EnterTech.USA, or you can email jim.strandlund@EnterTech.USA or john.pendleton@EnterTech.USA. But basically, this is going to walk you through how to check. So remove the terminal bars, check terminal bolt torque, and clean terminals. And again, install compressor, 0.5 to 20 mega ohms. It's clean. It's a clean system. If it's less than 0.5, you can condemn it. Again, 20 to 50 is okay. And again, that's just going to give you your baseline when you check it right off the bat. So that's basically the overview of a mega ohm meter and how we can study some trends of the readings you get from your compressor to see if you've maybe got some contaminated oil in your system. I will say that whenever you change out a compressor, you should probably check the oil in the old compressor for any contaminants. There's oil testing bottles that you can use. There's quick check if you still have refrigerant in the system. But I would always check the refrigerant oil in the compressor when you're replacing a compressor. And you also, you could take a mega ohm reading and that'll tell you if your oil is contaminated as well. But again, always check that when you're changing a compressor. If you do have an acid burnout in a compressor, we do have a technical bulletin or a technical tip that will walk you through on how to do an acid cleanup, because we don't just want to throw in a new compressor, put a new filter dryer and let it run. We're probably going to put in some suction line cleanup dryers and oversized liquid line dryers. Normally the dryers will need service ports on them so we can check pressure drop so that we know when we need to replace them or remove them from the system. So that's just a little bit on the mega ohms. If you have questions, please reach out. If not, thanks so much for joining us today, and have a great week.